Welcome to Get Fact.
Oh.
Good morning. Or
Good morning.
Or if you're listening when this gets released, good evening.
Yeah. We're not used to doing it in the morning, the recording.
Oh, I'm still asleep.
Yep. I feel like a schoolboy.
Yeah, just got up from school.
Nice and early. And today our guest is going to be another mind-blowing guest. And it's too early to be learning, but let's see how we get on.
My mind was blown just waking up.
Yeah, that was a struggle. Are you looking forward to your holiday?
I am, yeah.
When do you go away? 28th?
29th.
29th?
Monday the 29th.
So when this is released, it'll be tomorrow. You going away tomorrow?
I'll go away tomorrow. Yeah.
Yeah. So have you got any plans for what you'll be doing?
We're hopefully going to be doing a quad bike tour and go out on a boat to an island where you can jump off and stuff like that. Swim with the fishes.
Swim with the fishes? You're going to swim with like dolphins or...
No, just fish.
No mammals? No, just fish?
Just fish.
No. What type of fish? Do piranhas class as fish?
I think
you swim with them?
Oh, well. I'd like to say no.
What about the sea cucumbers? If you find one of them, pick it up, Robert. $2,000.
I'll see how much they are when they're all cellophane wrapped.
Yeah. So, have you got anything planned for the weekend other than going away, leaving me?
Packing.
Oh yeah, it's always that busy moment, isn't it? It's getting everything into a suitcase that doesn't fit.
It's not that. It's watching the missus flap around.
Yep.
Losing her mind.
Yep. It's surprising how much you can get in a suitcase, though, isn't it? When you fold it correctly.
Yeah.
It's weird. It's like that's never fitting. Then you close it, it goes. Zzz, eh? It didn't look like it food sticking out half a mile.
This is the thing about weights as well now, isn't it? You've got to be careful.
The what? Weight?
The weight,
oh, yeah, it's dodgy, innit?
If you go like a kilo or a gram over,
yeah,
you get charged.
Really?
I think so, yeah.
How much?
I don't know. That's why
I know it's extortionate.
I tend not to go over.
Try and keep it to a minimum. Oh, they'll do a little bit under, don't you know, to be safe.
I'll have to go with 1 day's less worth of boxer shorts.
Yeah, that's the thing. You come back with more, don't you know? Because you got gifts for everyone.
But why is it always a struggle packing your case coming back?
I know. It's because of all gifts. Just get everyone a keyring. It's cheaper and easier. Just pack a lot of keyrings. I've just sent myself a little video. It's about global cooling. This is a weird little video.
Bill Gates doesn't think of himself as some guy who got super rich making bad software. Bill Gates thinks of himself as God, in control of the solar system. And that's why Bill Gates is now backing something called sun-dimming technology that would reflect sunlight out of the Earth's atmosphere, causing global cooling. Ooh, that's not fraught with risks. You thought gain-of-function research on pathogens was dangerous. Try that. But that doesn't stop Harvard University. Its scientists are testing that technology by spewing calcium carbonate dust into the atmosphere.
Bill Gates is backing the first high-altitude experiment of one radical climate change solution, creating a massive chemical cloud that could cool the Earth. It's called solar geoengineering, and it's highly controversial. It would look something like this. Thousands of planes would fly very high and use nozzles to inject millions of tons of light-reflecting particles into the stratosphere. It would create a thin chemical cloud of those particles around the whole planet, blocking some sunlight from reaching the surface. It would mimic a giant volcanic eruption, which we know cools the Earth.
Well, that's weird, isn't it? What do you think of that?
I don't know if I believe that.
Global cooling.
Seems a bit too propagandish.
This is where it goes into like alien species type thing. You start trying to control the weather.
Yeah,
that's a bit weird.
I don't know. That seems to be a bit too propagandary.
It does, doesn't it?
Bill Gates.
Yeah, it does, doesn't it?
Yeah. I mean, are certain countries going to allow these planes to fly over their airspace?
Maybe, I don't know. Well, it's like chemtrails, isn't it? That's kind of a similar trick, isn't it? go free with planes and spew a load of whatever they're putting into the atmosphere.
Oh, well, watch this space, I suppose.
Yeah, just watch above your head. If you see a load of weird chemicals coming into planes, you know it's global cooling.
Those aren't vapor trails.
Yeah. I don't know if that's a good thing or a bad thing. Is global cooling supposed to be good? I thought that was a worry.
I think we should just let the Earth progress how it's naturally meant to. I think all this global warming is part of the evolution of the Earth.
Right.
We've had an ice age.
Yeah.
We've come out of that. We've had our time, and now what's to say we're not going into a hot age or?
Yeah. Do you think we're just going to evolve with it, like Magna Men? I can't say that Magna Men. That's what
Magna Men. Yeah. I don't know. Maybe we'll evolve with it. Maybe we'll die out like the mammoths did after the end of the ice age.
Maybe them snails in volcanoes have already evolved, ready for it.
Maybe.
We're behind.
And then in millions of years' time, someone can then bring us back like they did with the mammoths.
But I don't think we're saying because they got frozen. We melted.
Oh no, they got frozen, died, didn't they? Well, they couldn't survive. They didn't freeze. They couldn't survive because the Earth was warming up. And
I thought it was they all froze. I thought that's what I was finding, like full frozen mammoths.
Well, no, I think it was because the Earth was warming. They couldn't find the food that they needed.
Right.
Obviously, some of them starved.
We need somebody on that knows more.
We do. We need a paleontologist.
Yeah, that's what we need. Yeah, people that dig stuff up, find out more about it. You know, how I've been saying codswallocks.
Yeah.
Yeah, it's wrong, isn't it? It's codswallop.
Well, that's what I thought. I thought you knew better. I thought it was a Wiggins thing.
I've always said codswallop because I thought it was like an interpretation, like bollocks.
Well, you know, like, I've just said that.
Up the apples and pears and that. I thought it was like that.
Cockney rhyming slang.
Yeah, I thought codswallop, I thought bollocks. But apparently codswallop means this. It's probably an alteration of codwallop, a person who deals in or handles fish. Also a foolish person. The current sense was popularised and possibly coined by British writers, Alan Simpson. So I've been wrong, but I think I'm going to stick with it. That's my phrase, codswallocks.
Codswallocks. Well, yeah.
Codswallocks.
You've created your own phrase.
Yep. I'm going to have fish with testicles on it. For the picture. Get that on a t-shirt.
Oh, that'd be great. How do I explain that one when I go to Greece?
Yeah, on your back. Why's that fish got like huge, space hoppers on its back?
I used to love that, my space hopper.
You did?
Yeah. Went everywhere with it.
I used to have one. I think everyone's had a space hopper.
I think everyone did.
Yeah, and it changed into like one of them big exercise balls when you get older. Yeah. You're still bouncing them like a kid.
Oh, I'm having lots of fun.
Yeah. Did you have pogo sticks back when you was younger? I know pogo sticks have been around for a long time.
We did have pogo sticks. Yeah. I never had one. A friend of mine did, and I had to go. Couldn't do it, so I didn't like it.
You couldn't?
No.
I remember like my mate went in for his tea, and I was trying to do a world record, and I stood in one spot, I was bouncing. While he had his tea, it was about half an hour bouncing in one spot. That must be some kind of record.
No, I just couldn't get the balance right on it.
You couldn't?
No. But then I gave up too easy instead of just sticking at it.
Right.
Which is what I try and teach my daughter. Stick at it.
Yeah, stick. It is. That's what we're trying to do with the podcast. Stick with it.
Stick with it.
And it will adapt.
Please sponsor us.
The desperation in your voice.
Got my puppy dog eyes on.
Did I tell you about Jack yesterday?
No.
Remember on the podcast where I spoke about me losing my dog in the fog?
Yeah.
He went yesterday as well. Disappeared. So I didn't even know he disappeared though. So basically what happened was I was washing my car yesterday because it was a sunny day, and somehow he must have got out without me noticing. I've gone and picked Oliver up, driving round and whatnot. I've been out for about half an hour. Then I got a phone call off my sister saying, we've had a phone call saying Jack's at the vets. I was like, what? I was like shouting Jack because I was at home. And I was like, Jack? What are you on about? Jack's in? And then he weren't in the house. I was like, crap, he's gone out. So I was like, because he's microchipped to them still because I've not changed it. I didn't even know you had to change it. Have you seen the fine on that if you don't change it?
No.
Get a grand fine if you don't change it.
Oh, Christ.
I said my dog's not worth $1,000.
Our cat needs changing.
Cat, I wonder what a cat is, £500.
I don't know.
But yeah, I had to go pick him up from the vets, which is about 20 minutes drive home. It's just like, where have you got over here? Homeward Bound again? Homeward Bound 2.
We used to be able to do that years ago. I remember as a kid, we used to get up of a morning and we used to just let the dog out.
Really?
Yeah.
Like, I know a man that...
I don't mean like just into the front garden. I mean like literally out.
Yeah, take himself for a walk.
Yeah.
And there's a man at a garage that does it.
And then she'd come back and scratch at the door and he'd let it in.
I'd love to stick a camera on him, see what he get up to.
I know, yeah.
On the little journeys. You see him walk past other dogs. What? You looking at? Yeah, you better keep walking. Anyway, I didn't realise the time. Our guest is on at, 10 a.m. It won't be 10 a.m. to you listening, but that is in 5 minutes to us. So we're going to have a little minute before he gets on. Let's get ready.
Cue the music.
See you in a minute.
Down, dig.
Hello, guys. Can you hear me okay?
Yeah.
Yeah, we can hear you. I think it's just loading up now. I can't see you.
Oh, no, you won't see me. Is that okay? Because I'm on a new computer. I've not actually set up my webcam.
All right. Yeah, well, the podcast is mainly audio anyway.
Yeah, and also my bandwidth's terrible because I have awful internet connectivity issues. So just not having the video on just helps, maintain a bit of stability. Plus, I'm not very pretty, so you're not missing anything.
So how are you anyway?
I'm not too bad. So it's Stephen and
Stuart.
Yeah.
I listened to the podcast with James. It was good. It was a lot of fun.
Yeah.
But I haven't had a chance to listen to many other episodes.
Yeah, no worries.
I've been super busy for the last couple of weeks. So.
Right. Well, I'm hoping you can educate us on some things.
Well, yeah, but don't try and pass any exams with them. And then come to me and go, you really let us down, Rob.
Yeah.
We went into our exam and wrote everything you said, and apparently it's a load of rubbish. Because obviously there's a huge difference between, a formal understanding of the kind of stuff that me and James talk about, and then the way you present it to the public's actually slightly different.
Yes.
So, it's not. It's a strange thing. Like physics is like Russian nesting dolls. Yeah. And you the physics you get taught at school, then you get to university, it's like, forget all that, that's all wrong.
Right.
And you're like, oh my God. And then you learn about things like general relativity and quantum physics. And then if you go further, it's like, okay, here's quantum field theory, and all that stuff was also wrong.
Right.
So it's physics is all about models. So it's presenting the best kind of model to the public.
Yeah.
That they can easily understand, and it's a fairly accurate description of reality.
Right. Mine's blown already.
Yeah. Sorry, we didn't even introduce you. This is Robert Lea to the listeners, and you work at space.com. That's right, isn't it?
I'm a freelance journalist, so I work at a variety of places, but the last few weeks it's mainly been space, but also worked for Popular Mechanics, Life Science.
Right.
I was at Newsweek for about 9 months, so I kind of jump around from place to place. So, which suits me actually. It's nice to have a bit of freedom.
Yeah. So you said you was going to talk a little bit about multiverse and quantum physics. So what can you tell us about the multiverse?
Well, it's interesting because obviously the multiverse is kind of... I don't know if you guys are fans of the Marvel movies.
Yeah.
There was a great film last year that really cleaned up at the Oscars called Everywhere... I forgot what it's called.
Everything, everywhere, all at once.
Everywhere, all at once. Yeah. So the multiverse is really popular at the moment. But what's interesting is the term multiverse actually comes from cosmology, and it's very different than the idea that's presented in the Marvel universe of kind of different versions of our universe.
Yeah.
So what an actual cosmological multiverse is, it's kind of the idea that there are other universes, like our universe would be a little bubble in this wider collection of universes. And those other universes might have completely different laws of physics. Right, so those bubbles our bubble seems to have the right numbers to continue to expand and to grow and to allow structures to form that eventually, facilitates life existing. But other universes might have completely different numbers that causes them to either grow way too fast for any large structures to form, or it might cause them to grow a little and then completely collapse, or they may never grow at all. So the idea of, if you actually presented a multiverse of madness in Doctor Strange that's based on a cosmological idea, it'd be essentially Benedict Cumberbatch exploring all these worlds where nothing else happened because the laws of physics are completely different, which would be a bit boring. I don't know how you'd work a Bruce Campbell cameo into that. So what the multiverse that we kind of see in film and TV, think Spock with a beard, an evil Spock with a beard. So I can see one of you at least as an evil version of yourselves there. That kind of multiverse idea actually comes from quantum physics.
Yeah, right.
So there's an interpretation of quantum physics called the many worlds interpretation, and that suggests that every time a quantum decision is made, every possibility creates its own universe. So that is much more similar to the idea of the multiverse in pop culture. So it's actually a many worlds theory. As I point out as I go into every Marvel film, and my 12-year-old son's like, "Shut up, Dad! Let's say just watch the film. Get down from the front. People don't want to hear it." So. So, and the interesting thing about the many worlds interpretation is, one of the big problems with it is it suggests like this kind of exponential growth. So every time you turn on a light switch, for every photon that light bulb's throwing out, every one of them would have trillions of possible trajectories.
Right.
And each of those would create a new world. So if you think about it, the problem that physicists really have with the many worlds interpretation, the ones who don't support it, is the collection of universes would be near infinite from just the tiniest little decision that we made. Turning on a light switch would create, this near infinite set of universes just that only differ in the path those photons took when the light bulb was turned on. So that's why it's, for a lot of physicists, it's untenable because you really can't even calculate it. It's so massive.
Right. So is this like loads of different pathways almost that just that one switch has done?
So in quantum physics, it kind of does away with the idea of trajectory. So think about an arrow fired from a bow. In normal physics, we can, from where that arrow lands, we can kind of work out the path it's taken.
Right.
But in quantum physics, there's no such thing as a single path.
Right.
Everything could have travelled an infinite amount of paths to reach its final destination. All we know is where it was emitted, where the photon, say, was emitted from, and where it actually ended up, and it could take an infinite number of paths to get there. So the idea of quantum physics kind of destroys trajectory. Right. And then many worlds would say, okay, so that for every path that photon could have taken, there's a world for that in which it took that path. So
right.
The easiest way to think about it is Schrodinger's cat. I'm sure you've heard of that, like, theoretical experiment.
It's what, sorry?
The easiest way to think about it is Schrodinger's cat. So I'm sure you've heard about it. A physicist takes a cat and he puts it in a box with a vial of poison that breaks based on an atom decaying. So if the atom decays, the vial of poison breaks, the cat dies.
Right.
And then he seals the box. So if that box is a quantum system, until he opens the box, it's described by waves. So waves stacked on top of each other, and each possibility of is the cat dead or alive is a wave. So until the box is opened in quantum physics, you can't know if the cat's dead or alive.
Right.
So it exists in a state of both. Schrodinger's cat's both dead and or alive. Now, when the box is opened, those waves collapse to a single wave, and you know the cat is suddenly either dead or alive.
Yeah.
Now, what many worlds would say is you're not opening the box to discover if the cat's dead or alive. What you're actually opening the box to discover is if you are now in a world where the cat is dead or alive. So you might be in a world where the cat lived because the vial of poison never broke, or you might be in a world in which the atom decayed and the poison broke and the cat is now dead. So that it's what happens at the moment of opening the box. That's the big mystery about quantum physics.
Right.
What happens at the moment you open the box and look at a system or try to take a measurement of the system? What causes that collapse? And the many worlds interpretation says there is no collapse. The wave function grows, it swallows you, it swallows the lab, it swallows the entire universe, and you suddenly become part of that system where you could be in a world where the cat's dead, you could be in a world where the cat's alive.
Right. I'd never heard that.
That's a good conversation starter, isn't it?
It is. I was just trying to get my head around it then.
It is mind blowing, but that's where the whole mystery of quantum physics comes. What's happening when we take a measurement of a system? What causes that system to collapse and suddenly take a set value?
Yeah.
Okay. So how are scientists trying to understand? What are they doing to study the multiverse?
Well, the actual multiverse itself, so like the many worlds interpretation, part of it hinges on the idea that these separate universes can't interact with each other.
Okay.
So there may actually be no way of knowing if there's another world somewhere where, you know, everything's different or just slightly different apart from this one thing. There's no way of crossing between those worlds to discover that. Right. But there's loads of interesting ideas for a cosmological multiverse with lots of different universes growing like bubbles in, you know, like soap.
Yeah.
So you kind of, you've got these bubbles growing and some collapsing. The problem is that our universe is expanding so quickly that we can't see past a certain horizon. We've got like a cosmic horizon, and past that we can't see. Now, any of those universes would exist beyond that horizon, so there'd be actually no real way of visualizing them.
Yeah.
There's another idea. I can't remember the researcher who's behind this. I can't remember his name. But there's an idea that beyond the event horizon of a black hole lies another universe. And that there are baby universes beyond that event horizon. Now, the guy who suggests that says that there may be a way of discovering if that's true. If we ever looked at our universe and discovered that matter favors a particular direction, so it's denser in a certain direction, which which we don't see at the moment. It's pretty much evenly spread and homogeneous across the entire universe. Yeah. But if we ever found a favoured direction, that might suggest that our universe exists beyond the event horizon of a black hole in another universe. It's a very new theory, and at the moment it's just completely hypothetical.
Yeah.
But that's his idea of what the multiverse is like. So every black hole in our universe would have its own baby universe hid behind there.
Oh, okay.
Right. So have they ever tried to like send a camera down there?
You can't. The problem is that black holes are so. You get a massive star and its core collapses, and you create this region of infinite density called a singularity.
Right.
And that's the center of black holes. Now, the problem is a black hole has a second singularity, which surrounds it like a sphere, and that's called the event horizon. Now, the gravity of the black hole is so intense that at the event horizon, the escape velocity is the speed of light.
Yep.
So light can't escape from that beyond that point. That's a lot. So when have you seen the images of the black holes?
Yeah.
So that have been captured by the event horizon. That glowing ring, the inner edge of it, that's the event horizon, and then beyond that, you've got complete darkness because light can't escape from that region of the black hole. So you can't see beyond that point. Right. There's no actual real way of investigating beyond the event horizon. So that the only way we could find out if that cosmological model of universes behind event horizons is correct would be by discovering if we're behind an event horizon, which would be that, if the universe favored matter in a particular direction, that would imply that could be true.
Right.
But it may be something that we never know. I think it might be beyond our capabilities of ever discovering that.
Right. Because obviously, like, there's been a few films now where like they use black holes, to enter different universes. So that you don't think that'll ever be possible?
No, because another problem with black holes that arises from that intense gravitational force is when you get too close to the central singularity, you get something. The tidal forces become so great that, say it was you entering Stephen, the gravitational force at your feet. Sorry, Stuart, I'll throw you into it as well. You look really crestfallen then. It's like, why does he get to go into the black hole? So the gravitational force at your feet would be so much greater than that at your head that you'd stretch out. Scientists call it spaghettification, which, isn't as pleasant as it sounds. Now, for like a supermassive black hole like Sagittarius A star...
Sorry, can I just shut this window? I can hear all that. There's people doing the lawn mowing.
So for Sagittarius A star, which is the black hole at the centre of the Milky Way, which has about 4.5 million times the mass of the sun. So it's like 4.5 million suns crammed into an infinitely small space.
Right.
For that black hole, the event horizon is further out, so you wouldn't even know you'd crossed it, and you wouldn't start to spaghettify until you'd crossed the event horizon. So we'd all be spared the sight of you being stretched into a strand of spaghetti, which is good for us, less good for you. But smaller black holes, that spaghettification happens before you cross the event horizon.
Right.
So we can see it then. So that's the problem with investigating into a black hole. So, apart from the fact that no signal could ever escape the boundary that's the event horizon, you'd just instantly be killed as soon as you got too close to the, probably no matter what you put into a black hole, it'd just be destroyed. So
So, do you think there'll ever be any possibility of seeing another universe?
No. No,
Straight up, no.
No, I just don't. I think it's beyond the limit of what we can know. I think we might be able to pick up clues, and we might get hints. Yeah. But like for example, the many worlds hypothesis of quantum mechanics. There are two schools of thought with quantum physics. There's one that's very popular that's just shut up and calculate, and we shouldn't think about these things because we can't ever know if many worlds exist. We can't know, so we might as well just forget about it and work on what we can know.
Yeah.
And that approach has been incredibly successful. You know, we use quantum physics now as part of our everyday lives. You know, we use it in banking, we use it in security, and it's become really successful because we've focused on what we can know and what we can use rather than what we can't.
Yeah.
So with quantum physics, I think that will forever remain the remit of philosophy. Right. You know, when you interpret it, I think it's fine. We can say what we see, but we'll never be able to say why we see it, if that makes sense. Yeah. And with cosmology, I think it is something that would be scientifically possible to observe, but it's beyond our reach, and the universe is accelerating faster and faster all the time. So the chances of seeing to the edge of the universe just gets, if it wasn't already impossible, it just gets less and less possible all the time.
Right.
So no, I don't think we ever will.
Right.
Well.
So you know, I'm going to jump to the Simpsons when he's writing on a blackboard. Isn't that the theory of everything that he writes on there?
I have absolutely no idea. I don't know. I don't know. There might be an episode where he's wrote the theory of that. Of course, at the moment, there's no theory of everything.
Right.
If you like, if there was a single equation to completely describe the universe, there'd always be a line missing.
Yeah.
And the line that's missing is, so you've got quantum physics, which we've talked about a lot, and that's great at describing the really small. And then you've got general relativity, which was developed by Einstein in 1915. And that's really good at describing things on a massive scale. And then you've got everything in between. And general relativity meets up nicely with everything that's in between.
Yep.
Quantum physics does, but in a fuzzy way. We don't quite know where the dividing line is between quantum physics and, say, the physics of that cabinet behind you or your Yankee candles.
Yeah.
That's a bit more fuzzy, so we don't quite know where quantum behavior stops and where it becomes behavior of the normal world. But what we can't link up is general relativity doesn't link up with quantum physics. So general relativity doesn't unite with quantum physics because there's no quantum theory of gravity at the moment. Right. So that's the line that's missing from the theory of everything. So if Bart was writing that on the blackboard, then he's not going to be able to complete it because there'll always be that missing line.
Yeah.
You should keep going though.
So I tried to do a bit of research on quantum physics, and I was lost at atoms. I don't even know what an atom is. So what is that? An atom?
Well, atoms are... There's that joke that my son tells me every 3 weeks. Why should you never trust an atom, Dad? Because they make up everything.
Right.
So atoms are the fundamental building blocks of the matter that we see around us on a day-to-day basis. Basically, you've got a nuclei of protons and neutrons, and then you've got electrons that kind of buzz around that nuclei. But what I was saying before about how you kind of go from school and you learn something about the world and physics, and then you go to university and they go, okay, that was all wrong. So kind of the model that we've popularized of the atom in school is like the neutrons and protons sat neatly in the middle and electrons orbiting around, say like the moon orbits Earth.
Yeah.
But actually, it's much more complicated than that. Electrons follow certain paths, but they kind of buzz around, and you can't really ever say where they are. So it's actually much... Sorry, I've just set off my Alexa. I don't know what I said, but it's just like triggered her. She's decided to tell me about physics. So the electrons kind of buzz around. So that's atoms, and then quantum physics would kind of be the layer beneath that, really. But again, we're pushing the limits of quantum physics all the time. So we're finding quantum phenomena, things like entanglement, in larger and larger collections of atoms.
Right.
So we can't quite find that line where we say, okay, quantum physics stops here and then normal physics takes over. It's very fuzzy, like an electron orbiting an atomic nucleus in a way.
Right.
Is that what they were trying to do in Sweden when they did what was known as the God particle? Is to try and find that bridge between what you were saying before with that missing piece?
I mean, a lot happens at the Large Hadron Collider. So there's actually a lot of science you can get from smashing atoms together.
Yeah.
So yeah, that would be part of it. They're not strictly doing quantum experiments because you don't quite need that much energy to do, to investigate something like entanglement. See, what the Large Hadron Collider is really good at is investigating what the conditions would have been like in the early universe, when the universe was much denser, much hotter, and much more energetic. And they can kind of replicate those conditions by smashing protons together. Okay. And what you get there is when you hit, two atoms together or two protons together, you get a cascade of particles that's created. So you can look at that cascade and look at the particles, because the thing about the particles that exist in those collisions, they don't last very long.
Yeah.
They last fractions of a second. So by looking at the cascade, you can work your way backwards and look at the particles that were created by that collision. That's how we found the Higgs boson, which a lot of people call the God particle.
Yeah.
And now where they're kind of at with the Large Hadron Collider now, it's just undergone a upgrade, which means we get more collisions. So it's producing more of these particles, more of these cascades, and when it produces more, there's a chance of seeing more exotic physics, if you like.
Okay.
But what they're kind of looking for at the moment, the discovery of the Higgs boson really completed the standard model of what we call the standard model of particle physics. It was the last little puzzle piece that was missing from that. Right. But now what they need to explore is physics beyond the standard model that the standard model doesn't quite explain. So you've got things like dark matter and dark energy, and they're not part of that standard model. So we have to explore further to discover what those kind of things are. So we need more collisions and more data to go through to better understand that. So that's where it's at the moment.
Right.
Okay. You just mentioned something that I was going to ask you about. What is matter and dark matter?
Yeah.
Right. So dark matter essentially it accounts for the majority of the mass in the universe. What is it? We don't know.
Right.
We know what it's not, and what it isn't is matter like that can, makes up your cabinets and your whiteboard and your headphones and Earth and the sun.
Yeah.
And the reason we know that is dark matter it either doesn't interact with other matter or it interacts very weakly. So you could pass through dark matter and be completely unaware that you'd encountered anything, whereas you might have difficulty passing through that cabinet in the same way.
Right.
Also, dark matter doesn't interact with the electromagnetic force.
Yeah.
So it doesn't give off light, it doesn't reflect light, it doesn't absorb light. So it can't be seen. We know it's there because we've discovered that galaxies are spinning so fast.
Yeah.
If they didn't have this extra gravity from this invisible mass, they'd just fly apart.
Right.
So there must be something holding them together.
Yeah.
We also use something called gravitational lensing, which is really fascinating, to kind of investigate dark matter and see how it's distributed. So gravitational lensing is gravity arises according to Einstein's theory of general relativity because mass causes a curve in space-time. So think about taking a stretched rubber sheet and placing a bowling ball on it.
Yep.
It creates a dent, and objects of mass do that, but in 4 dimensions rather than just 2 like the stretched rubber sheet.
Yeah.
Right.
Now, if you roll a marble past that bowling ball on the stretched rubber sheet, its path curves.
Yeah.
And the same happens for light. So if light from a background source is shining past a galaxy, the curvature in space bends that light,
Yeah.
which would normally travel in a straight path. And by seeing how much it's bent, and by how that curvature changes as the light passes closer to the source of the mass, we can kind of measure the distribution of dark matter.
Right.
So we know there's something there.
Yeah.
What we don't know is what it is. We can just say it's
yeah.
not like matter around us.
Right.
But there are a few leading theories, but there are things like really entertaining particles called WIMPs, and then there's machos, which are, WIMPs are weakly interactive massive particles, so that would be quite large but don't interact with matter.
Right.
But at the moment, it's all theoretical, and we just don't know what dark matter consists of.
So you know how you said the light goes past the planet almost and then goes with a curvature? Would that be one of the things that debunks flat earthers?
Well, I mean, take your pick. It's not an exaggeration to say, if I had to write every time I wrote an article and I had to write, and this debunks flat Earth, I'd never get finished, because it's an idea that is so, just on the face of it, ridiculous.
Right.
That, and no offense, I don't know, you guys might be flat earthers. I doubt it. I doubt it because you've got your headphones on your heads and you're not struggling to put them on, and which is unfair, because I don't actually think, a lot of people think flat earthers are stupid, and I don't actually believe that. We've done surveys. We've done surveys of people who believe in flat Earth, and they're actually quite scientifically literate.
Yeah.
Because you have to learn a lot about science to do the kind of mental gymnastics that they do to justify why the Earth's flat. So they actually become quite knowledgeable. There's just something that's gone wrong in the way they process that information that's led them to a faulty conclusion. And the problem is that, I'm sure you've all got relatives like this, I know I definitely do, where they believe something, and the more you fight them on it, the more you present them with like logic and evidence, and the more entrenched they become in that belief. And they feel like they're under attack. And that's why it's so difficult to dissuade someone that the Earth isn't flat, because they feel like they're under attack. And I don't help when I say things like, imply they're stupid, because they're really not. It's just, there's something's happened where, there's kind of a block somewhere, and we're all subject to that. We all have beliefs that we know aren't logical and sound, but we're still going to hold them, and that's kind of what's happening. So it's actually, and the fact that you can't educate a flat earther out of flat Earth belief means it's really problematic, and you kind of get this whole toxic environment, because how many of the United States, how many people would you estimate believe the Earth is flat?
Probably about 10%, something like that.
What do you think, Stuart?
Yeah, I mean, I agree about 10 to 20%.
1%.
Okay.
Yeah, I thought it was more than
1%.
that, especially in America.
When the American population were surveyed, 1%, far more of the American public believed in things like possession and the devil and ghosts than actually, and Bigfoot, than believed flat Earth. The problem is, flat Earth beliefs become amplified, especially on YouTube, where you kind of have these debates between people who are screaming at each other, and the subject isn't advanced in any way, shape, or form. It's like that old adage, empty vessels rattle the most.
Yeah.
And flat Earth's kind of the ultimate empty vessel. It's been blown up beyond all proportion of how many people actually believe in it. Because I was stunned when I read, the level of beliefs like 1%. Because when you hear that, you think, well, it's hardly a problem at all, is it? It's just the people who believe it tend to be quite vocal and quite loud.
Yeah,
about
you
that
find that
belief,
the
or at least
flat
some
earthers
of
are
them
actually
do.
quite aggressive towards the people that believe it's round and global. It's crazy.
Some flat earthers are extremely aggressive.
Yeah.
And I think that arises because of that feeling of kind of being under pressure and and feeling like everybody's against you and everybody wants to prove you wrong. And it's that. Similar to that, people who, anti-vaccination people who don't support the idea of vaccines, they become very entrenched and very aggressive. And when you're in that position and it's a major part of your belief system, I imagine it's quite easy to start believing, well, everyone's out to get me.
Yeah.
And I think that's where, because it's also been shown that people who tend to believe one conspiracy theory, they very rarely stop at one.
Yeah.
They kind of believe a lot. And I think it's when you feel like everybody's lying to you and everybody's against you that it's kind of easy to slip into other beliefs that are outside the mainstream.
Yeah.
So
another conspiracy is that they didn't actually land on the moon. Is there ways of proving that they did?
I mean, we've got reflectors that you could send a laser signal to the moon and reflect it back to Earth, and we if you've got a good enough telescope, you can look at the landing site for yourself.
You can actually see it.
You can go out and just look.
Right.
Same with the International Space Station. A lot of flat earthers don't believe that's orbiting Earth.
No, yeah.
Get a telescope. Find out when it's orbiting over your area of the world, and go look at it.
Yeah.
And then as soon as unless you think somebody's been tampering with your telescope, how do you explain that away? I think I've heard a theory that it's a hologram. Well, I think that seeing's believing sometimes, and I think if a lot of flat earthers actually went out with a telescope and looked at the ISS and kind of learned how the moon orbits Earth and followed astronomical objects as they travel around Earth, or as our position changed, they'd be dissuaded of the view. I think they'd have to do that on their own, though. You couldn't get a YouTuber called Science Bro Dude 24 driving out to a field and sticking their eye against a telescope lens, because they just think it was all a setup and it was all part of the plan to lie to them. So they've got to do it for themselves.
Yeah, I know there's other conspiracy theories that there's two suns.
Oh, I've not heard that one.
No, it's out there. Apparently, there's two suns. That's all I know, because I don't believe it straight up when I first heard it.
Where's the other one?
I have no idea. I'll have to look up on that one and bring it back to the next podcast. I suppose when you think about the sun as an astronomical object, there's way more than two. Right. So yeah.
the universe is filled with stars like the sun, but as for another one being in the solar system, I have heard. I'm sure there's a conspiracy theory that suggests, NASA are trying to ignite Jupiter like a second sun, which is one that's quite interesting. I mean, even conspiracy theories, if you read about them, you can learn something about it, because obviously if someone said, why isn't Jupiter a star like the sun, that brings up the whole discussion of where the dividing line between a planet and a sun is, because we're discovering more and more of these objects called brown dwarfs, and they kind of straddle the mass line between a planet and a star. So they're bigger than a gas giant planet like Jupiter, but they don't quite have enough mass to trigger nuclear fusion. Right. So they can't light up like a star like the sun. So who knows? Could there be a brown dwarf at the edge of the solar system?
Yeah.
Probably not. I don't know why I said that.
Yeah, I've just found something here. NASA hiding the truth that a second sun exists, claims astronomer Paul Cox.
I wonder if it's related to Brian.
I don't know.
Well, I think Brian would probably want to keep that quiet. I don't know. That's a first to me. I've never heard that one personally before. But I'd love to. I mean, like I say, you could learn something from it. I'd love to hear his logic and hear why he believed that. Because I can't think of anything that would make me suspect there's a second sun.
Well, he says this theory came to light during an 8-hour live broadcast with Cox, where he showed a live feed of his telescope examining the planets. Pointing to a black dot, which was the planet Mercury, Cox says that this is the location of the second sun, and rejected the idea that it was in fact the Swift planet.
Well, yeah, but that it would have to be tiny, and it wouldn't be able to sustain nuclear fusion probably, so it wouldn't be a star.
Yeah,
right.
So that is a really strange theory, and we'd. I mean, if the sun was actually in a binary system, because stars are more common. Single stars are actually, they're not rare, but they're not the most common configuration of stars. Most stars are found with a binary partner, or even in a system of 3 stars.
Right.
So the sun is actually quite unusual for sitting on its own. So, but the binaries, you can, even if one of the stars was completely invisible, you'd be able to tell from the motion of the other star. We've got so good at detecting changes in motion that are caused by orbits of objects that we can identify planets outside the solar system by looking at the tiny wobble that they cause in the motion of their star as they orbit it. So I'm pretty sure that if there was a second sun orbiting the sun, we'd know about it by now.
Yeah.
But unless NASA are covering it up, though.
Well, that's it. You see, that's what he's claiming to.
Why won't you tell us the truth? Someone's got to clip that, and I'm like never going to get anyone from NASA to speak to me.
Yeah, just cut that bit out.
Yeah, science journalist, unhinged rant on pod.
Yeah. So I don't know if you'd know the answer to this, but how people believe in ghosts? Well, I kind of believe in ghosts. Would there be a way of finding out if they're real by measuring atoms in somewhere?
So, personally, I don't believe in ghosts.
Right.
But I find the topic of ghosts really fascinating.
Yeah,
me too.
The reason I got into science journalism is because I used to run a little debunking blog.
Right.
And that's how I started writing. So I'd kind of look at the things that were said in, some of the newspapers about ghost sightings and ghost photographs, and see if I could explain them logically, which I'd say 8 out of 10 times you probably can. Yeah. So I don't actually believe in ghosts, but one of the most frustrating things for me is seeing the idea of quantum physics connected to ghosts.
Right.
Which is done quite often. And there's also energy, the word energy, has become this placeholder for things we can't explain.
Yeah.
You know, energy, vibration. They're very misused by believers who want to make ghosts sound more scientific than the belief actually is.
Yeah.
So the misuse, that kind of mystery of what happens when we open the box.
Yeah.
So that wave function collapse that opening the box and measuring a quantum system represents. Quantum physicists use the word observation. So they say when we make an observation of the system. Now, observation, to me and to most people, gives the impression of actually looking at something with your eyes.
Yeah.
Now, if you think about a quantum system, we're talking about particles that are smaller than atoms here. So the idea of looking at it with your eyes is ridiculous to begin with.
Yeah.
But the use of the word observation, so we make an observation on a system and that causes the system to change, has created this whole subculture where people think that a quantum system will behave differently if we are looking at it than if it does if we're not. So that's kind of raised the idea that it's something to do with our consciousness that causes the collapse of a quantum system, which really isn't the case. If an experiment was run and we took a measurement remotely from the Dog and Duck pub rather than the laboratory, it'd still collapse in the same way, because what you're basically doing is when you make an observation of a quantum system, you're forcing it to interact with another system, and that causes it to change.
Yeah.
Now, that's been used to kind of explain the idea that misunderstanding has been used to explain the idea that maybe consciousness exists outside of the human body.
Yeah.
And unfortunately, it really doesn't suggest that to me. It's kind of given rise to this whole quantum mysticism, where you get people selling all kinds of crazy products and they'll go, oh, it's quantum. Well, that explains how it works. And energy's the same when people say, okay, so Einstein said energy can't be destroyed or created. It can only be converted. So what happens to the energy that is us when we die? But the difficulty is that is the energy that makes up you, a lot of heat, some electrical energy and chemical energy. There is no life energy that goes somewhere after we die. You die, the chemical energy is dispelled as heat, your electrical energy dissipates, and you're left with just a lot of chemical energy in essentially a shell that doesn't work anymore. So when people say, well, where does your energy go when you die? Unfortunately, the truth is it goes back into nature. You know, the microorganisms that feed on you, and then they'll use that energy to continue, you know, their life cycles. And it's unfortunate, and it lacks mysticism, and a lot of people see it as a kind of cynical view of the world. Yeah. But look at that. And what we are is fallible little sacks of meat walking around on the surface of a very not flat planet.
Yeah.
And look at what we've achieved. Look at what we understand. Just you and I, we don't live that far apart, but when you spoke to James the other week, you communicate across the other side of the planet.
Yeah.
And you're talking about incredible objects that exist billions of light years away that we've seen with our tiny little limited lives. And what we've done is we've created something incredible. And if we could just all recognize that instead of just getting lost in mysticism, or just uniformly destroying each other, then how wondrous would the world be? I've just been writing about, I don't know if you've heard about the Axiom 2 mission that's just launched, and it sent the first woman from Saudi Arabia into space.
Right.
She's riding with another Saudi Arabian astronaut. They'll be the first Saudi Arabians to reach the International Space Station. Right. Missions like this are happening all the time. We're sending people in orbit around the planet. We're getting ready to send people back to the moon. We're seriously thinking about sending people to Mars.
Yeah.
We're taking images of black holes, these cosmic monsters that exist millions of light years away, that sit at the heart of galaxies. We're doing incredible things, and the universe is actually a really wondrous place.
Yeah.
And my issue with a lot of mysticism is it makes all that seem so small.
Yeah.
And it makes our achievements seem small.
Yeah.
When really we're answering some of the greatest. And for all we know, no living organism will ever know as much about the universe as the human race does right now.
Right.
No other civilization might rise that pictures the things we do, that images the things we do, that knows the things we know. And that, to me, is where the real wonder of the universe lies, in what we've managed to do.
Yeah. So as I asked James, I'll ask you the same question. Do you believe in aliens yourself? As you just said, we know more than any other living organism.
So, I believe that there is bound to be life somewhere else in the universe.
Right.
I feel like the universe is almost too large for that not to be the case.
Yeah.
Now, in intelligent life, that's a different question. Because if you look at the universe is 13.8 billion years old at our current best estimate. Life's existed on our planet for, if we're generous, about 1 billion years. That's an extremely small window on an extremely tiny corner of the universe.
Yeah.
And I think that life exists elsewhere in the universe. Whether that life will get the chance to evolve into intelligent life, I think that's much less likely. And I think the idea that we're being visited by intelligent life is unfortunately less likely than that when you think about the vast distances that it takes to travel across the universe. And that doesn't mean there isn't the possibility, but I think it would be quite unlikely.
Because I don't know if you've heard about that footage that apparently Logan Paul happened to capture.
I heard something about it. I can't say I've looked into it. Yeah, because
apparently some guy has got actual footage of like the clearest footage of like UFO landings and stuff, but he's kept it to himself. He's going to take it to his grave. Logan Paul offered him like £30,000, something like that, to view this, to have the footage, and he basically said no. He said, "Oh, can I at least see it then?" But Logan Paul actually had a chest cam, so he actually filmed all the footage of what he was seeing, and now there's chances that he's going to release that footage.
You'll forgive me for being a bit sceptical, because I had a mate. He was a wonderful fella. He's passed away now, unfortunately. And we used to call him UFO Rob for. And he'd come into the local pub and he'd tell you he'd caught the most incredible footage of UFOs.
Yeah,
you wouldn't believe it. You know it's incredible. This is going to change everything. I've sent it to the papers, but I think NASA are keeping it quiet because they're not interested. And he showed you. I remember he showed me a piece of incredible footage once, and he'd filmed a streetlight for 20 minutes, and that was his incredible UFO. I think the problem is, and not to disparage him because he was an incredibly great guy, really generous, huge heart, but he just kind of. Everything was a UFO to him, and I think just listening to "I've got the most incredible UFO" footage, it sets off alarm bells ringing for me. That when you saw it, it's like that's a street light, mate. That's a weather balloon, and of course the name UFO, unidentified flying object. To get that name, it only has to be unidentified to you.
Yeah.
you know, I could come along, or someone else could come along and go, well, that's a weather balloon, that's this, that's that.
Yeah.
And if you fail to identify it and you're the only person with the footage, well, it all hinges on your interpretation of what that actually is.
Yeah.
And it falls apart as soon as it's introduced to a second party.
Yeah.
It just goes, it's a duck. You know, it's a flying duck.
Yeah, they changed the name to UAP. What was the reason behind that?
I think because it's actually worth citing. It's worth studying a small proportion of the purported UFO sightings.
Right.
And I think when you call it, I think it's unidentified aerial phenomena.
Yeah.
When you change it to that, it gives it a bit more credibility, I suppose.
Right.
And I think the danger is when you find out people are like the UFO. The US government's really interested in UAPs at the moment. And I think when you hear that that's true, well, they must be investigating the chances that these are piloted by aliens.
Yeah.
And that's not... I don't think we should jump to that conclusion. It's kind of, well, no, they want to know what's in their airspace.
Yeah, yeah.
And they want to rule out the possibility of it being... We'd have to rule out the possibility of things like advanced spy planes or, you know, test military equipment before... Or even, you know, some weird physics in the atmosphere that we're not aware of before we start going, okay, you know, it's something from beyond Earth visiting visiting the planet.
Yeah.
So I think it's a legitimate area of study, but it's so hard to separate from, you know, the common perception of it, which is. Yeah. You know, you see something in the sky and you've immediately seen a UFO piloted by an alien, and you know you've got to eliminate the possible before you can start thinking about the fantastical. You know.
Yeah.
So.
Well, that happened recently in America, didn't it? With that balloon that they thought was a spy balloon, and they just shot it down with like a 20 gram missile.
I'm sure plenty of people saw that and identified it as a UFO.
Probably,
I'm sure they'd seen it a UFO until the news came out that it was a spy balloon.
Yeah.
So it's all UFOs are too. They're so murky because it's all open to interpretation, and you know, you think about things like just even putting a size on a UFO, because I see a lot of UFO reports where you know, the people who saw it go, well, it was X amount of meters wide. But you can't say that, because unless you've got something in the sky at the same altitude with a known width, you can't actually say how wide or how long that object is, because you've got nothing to measure it against.
Yeah.
So even things like just measurements, it was 100 feet long. Well, you know, you can't say that until you've actually measured it against something at the same altitude. You know, so or even something of a similar size at a lower altitude. You just can't. You've got to have a measuring stick to say how high it is. Is it huge or is it just close?
Yeah.
You know.
So I don't know if you've heard this theory before about the you know, you say the universe is expanding. Mm-hmm. Well, they say for something to be expanding, it needs to be expanding into something. So it's the box theory of, like, you know, believing, are we in a massive box that we're expanding into? Yeah.
Well, that, I mean, if you think about it like a soap bubble, that's maybe one of the things that would promote the idea of a multiverse. That, okay, are we pushing into this material or something that surrounds the universe? Are we kind of like a bubble growing within that? It's fascinating, and again, because of that cosmic horizon, because we can only see so far, it might be a question we never get to answer.
Right.
So, but it is fascinating because obviously the second you say it's expanding, well, expanding into what? If the universe is all there is, then how can all there is expand? There must be something outside that,
right,
for that expansion to pass into. But the expansion of the universe, it's a bit. So what I always picture it like is, imagine you get a balloon and it's half inflated, and you draw two spots on the balloon.
Yeah.
And you blow it up. Galaxies move apart like those two spots. It's actually the space in between the galaxies that's expanding, like the fabric of the balloon.
Yeah.
It's the space in between galaxies that's actually pushing apart.
Right.
One of the interesting things for me is the way you can only see that expansion when you look at an object that's truly far away. So when we look at supernovas that are, billions of light years away, we can see the effects of that expansion because it kind of stretches the light that's traveling to us from that supernova.
Yeah.
So it's not like the expansion of the universe, you put your Donald Duck mug down on your desk and then you reach for it and it's half a foot away and you're like, what? We don't see it on small scales, and that's why it's so flabbergasting to me. I had a researcher describe it to me like this once. So you've got two periods of expansion. You've got the initial expansion that happened at the Big Bang, where the universe is infinitely dense and infinitely hot, and then suddenly it bursts out, it starts to cool, and eventually it gets to the point where we can form atoms, and then we can form stars and planets. And then it stopped, or it slowed to a near stop. And then, for no reason we can discern, it started again.
Right.
Now, what that's like, imagine you take your kid to the park and you're pushing your kid on the swing. You give your kid one push.
Yeah.
And you step back and the swing slowly stops and your kid comes to a halt.
Right.
And then suddenly, for no reason you can explain, the swing jerks back up again. And it doesn't just jerk back up and then slow down. It goes faster and faster and faster.
Right.
And that's dark energy. That's that push from dark energy. It's that second phantom push on the swing that we can't identify what gave it that push and why, instead of slowing down, it's getting quicker.
I'd assume that my kid was cursed and I'd leave him.
Yeah. Well, I mean, carrying the kid on the swing analogy as well, it's worrying because eventually that kid's going to fly off the swing and land in some bushes or a duck pond. But what's going to happen to the universe? Because what happens to the universe, I think, is intrinsically tied to what's driving that expansion. Is the universe going to eventually reach a point where it's just complete heat death, expands to the point where, there's everything cools and it's like a frozen dead universe? We talk about the fabric of space. Could it rip? If you placed an object that's too heavy on your stretched rubber sheet we were talking about before, it's going to tear. What if the expansion? What if the universe can only stretch so much? And that's a set of theories called Big Rip. And then there's the other idea. What if it expands to the point and then snaps back? And that fits into Big Bounce, a set of theories called Big Bounce, where the universe would then rapidly contract in on itself.
Yeah.
And then when it reached a tiny point, you'd have like a second Big Bang, or maybe not even a second, maybe an nth Big Bang. Maybe this has happened a multitude of times in the past, and we can only measure the period of the current expansion, if that makes sense. So what if the universe snaps back, and then we call that Big Bounce?
Right.
So what is happening with dark energy, which I think is probably one of the greatest mysteries in physics at the moment, what is happening with dark energy may be intrinsically tied to how the universe dies eventually.
So do you think the universe will die? It will just stop, or will it just keep going in some kind of other way?
That's a huge question. Well, it's a huge question, and to answer that, we need to know more about dark energy.
Right.
We need to know why, because it was always there. It just didn't. There's just for a reason it started to dominate everything. Because now it's estimated to make up about 80% of the universe's energy and matter content is dark energy. But it was once dominated by matter. It was once dominated by other types of energy. But for some reason, it's now dominant, and its dominance is increasing all the time.
Right.
And that's why the universe just accelerates faster and faster.
Right.
Cool.
So, on this episode, before we chatted to you, I played a video that was about, apparently, Bill Gates is trying to do a global cooling. I don't know how true this is. Don't know if you've heard of it. Where he puts like a chemtrail almost into the air, and it puts a layer on.
Yeah, I mean, you've got all sorts of. There are interesting ideas. So you could. I don't quite know how that'd work, but if you had something reflective, maybe.
Yeah, that's what it's meant to be, like a reflective cloud almost that takes away a bit of the sun or something.
I just think when we kind of take measures like that, the problem is I think we're kind of looking away from the problem a little bit.
Right.
And it's kind of, don't worry, we'll carry on burning greenhouse gases, and we'll carry on putting, carbon into the atmosphere. Yeah. But don't worry, Bill Gates has got a plan.
yeah.
And it worries me because I think sometimes it diverts away from the actual problem.
Yeah.
And the actual problem is we know we need to make a change.
Yeah.
We know that we have to do it urgently. And any plan that would help is great as long as it doesn't distract away from the main effort of cutting the amount of carbon we're putting in the atmosphere, cutting the amount of methane we put in the atmosphere, all the greenhouse gases. And I think it's great, but you also kind of have to look and go, well, is it just distracting us from what we actually have to be doing? So all kinds of efforts, I think we're going to get to the point where we're going to need everything we possibly can to try and limit climate change.
Right.
So any effort's good as long as it's not an excuse to sit back on our laurels and kind of not do it. Because this isn't the worst thing about climate change is this isn't something we're just finding out about.
Yeah. We've
known for a long time that something needs to be done, and we've waited and waited and waited because the fact of the matter is we don't want to change. We've got comfortable lives. We don't want to change. We don't want to be told don't use your car. We don't want to be told don't use as much electricity because we like our lives. We like our plastic wrap sausage rolls. We like our air conditioners. We like our cars, and change is hard. And we're all like that. I'm like that. You're like that. And anybody who says there isn't, they aren't. They're either a very, very special human being or they're lying to you. But it's come to the point now where if we want our kids to have a livable world, we have to change. And we're seeing these terrible weather events.
Yeah.
That it's killing people. It's taking away people's livelihoods. We either change or the world will force us to change.
Yeah.
And it won't be pretty.
Right. Yeah.
So I'm all behind any effort as long as it's not used as a distraction.
Yeah.
From the actual effort of getting us to change our ways.
Right.
So,
and governments will use that kind of thing as a distraction. We know that one thing that governments excel at is dragging their heels.
Yeah.
And they will. Look at the situation with COVID. When Gordon Brown was Prime Minister of the UK, he spoke about the dangers of a global pandemic,
Right.
and we did nothing. We just sat back and did nothing.
Yeah.
How long have we known as a species that the dinosaurs were wiped out by an asteroid impact?
Yeah.
We're just now starting to think about, well, if an asteroid was heading to Earth, how could we possibly divert it?
Could we stop it?
We're thinking about it now, and because we'll deal with a crisis when it comes up, but when it comes to forward planning, if that takes money, we're not so keen on.
Is that not because we've only just got the technology though? Because obviously a while back we only just got planes and stuff. So
yeah, but why have we only just got the technology? Is it because nobody's been? Because if you think about it, we've been sending. When did the Hubble Space Telescope launched in 1990?
Yeah.
So we're talking. We've been putting things in space way before that.
Yeah.
You know, so it's not like we haven't. You know, we might not have had the technology, but the seeds for that technology existed. If that makes sense. You know, we how long ago did Voyager 1 and Voyager 2 launch? And they've now moved out of the solar system. So we've had the technology to do that kind of thing for a long time. We've just not actioned it because it didn't seem like a big enough threat. And I think one thing that might have spurred us on in that is you've had meteorites, like there was one over Russia where it exploded in the atmosphere over Russia and it shattered windows for miles and miles and miles.
Yeah.
And we were lucky it didn't make contact with the planet's surface. Yeah. And I think that's made people actually sit up and take notice and go, well, actually, we're talking about, you know, in the United Kingdom, we can't deal with a bit of snow falling from the sky. How the hell are we going to deal with an asteroid falling from space? You know, it's crazy. The infrastructure just isn't there to deal with it. Yeah.
So just going back to...
Oh, that's a bit doom and gloom, isn't it? I've depressed myself.
Just going back to the global warming, I get that as humans we're probably accelerating it, but do you think that's part of the evolution of the Earth as well? That because we once had an ice age, we've come out of that. Is it possible that we're heading into a hot age or something of that description?
There's always going to be a natural rise and fall in the temperature of the planet. That happens, and you'd have to speak to a geologist more specifically. But what we're seeing with climate change and global warming, the reason we know it's a problem, is the spikes in temperature that we are seeing are beyond the variations that we would expect for a natural flux of the planet's temperatures. Right. So we can see that the acceleration of those temperatures is and still you're still going, because I think as humans we have trouble dealing with big data. Yeah. So what we'll do is you know we'll pull back the curtains and we'll see it's raining and we'll go, oh, global warming. It's been terrible this summer. It's been freezing. Global warming. What a load of rubbish. And we'll go sit back down. But there are natural variations in data. So you might have a very warm year. You might have the hottest year on record, and then you might have a colder year. But the trend is up. And when you look at the data as a whole, and when you track it back to the 1950s, you can see that the trend is up. And just one cold year won't change that. Just like one day of rain won't change that.
Yeah.
So what we're seeing is outside that natural variation that we would experience with the planet's temperatures. So, and again, that's something that we've got to fight against to get people to see the bigger picture. You know, and it's not easy, like dissuading flat earthers. It's not easy to get people to look at that bigger picture for themselves. Yeah. So that's the fight that climate change that climate change advocates have got But I think it's getting better. I think people are starting to accept it more.
Yeah. So,
go on. Sorry.
I don't know if you know much about the quantum computers they've made.
Mm-hmm.
The apparently it's like 1 million times smarter than the supercomputer we have now.
Yeah.
So when that happens, and they make an AI that's got a quantum computer, would that be more intelligent than humans?
I'm not a computing expert, so
Right.
It's well out of my kind of realm. But I think the problem with AI ultimately is humans will always be able to do one thing better than AI, and that's we kind of create and we can change our patterns of thinking, and an AI will do what it's programmed to do.
Right.
It will do what it understands, but is there room outside that for deeper understanding? And I think that's something that I think AI will always be, as much as we'll come to rely on it for more and more things, it will always be that step beneath humanity because of that level of creation. I mean, quantum computers are really interesting because we were talking earlier about measurement and opening that box on Schrodinger's cat.
Yeah.
So quantum computers rely on keeping that box closed.
Right.
Of keeping quantum systems undisturbed.
Yeah.
So at the moment, they have to be kept away from electromagnetic fields because that could open the box.
Yeah.
They have to be kept incredibly cool because the slightest change in temperature could open the box. Because quantum systems are incredibly delicate.
Yeah.
As mysterious and wonderful as they are, and as good as we've got at using them, they're still incredibly easily disturbed, and that's why quantum computers at the moment aren't very reliable, because you'll get to a certain length of calculations, and then something will disturb them, and they'll become unreliable. So I don't know if we'll ever have. I know people talk about quantum supremacy and the advent of quantum computers, and I write about it a lot. But I don't know if we'll ever have a working quantum computer replacing your HP desktop.
Yeah.
I don't know if it's possible because I just think the delicacy of, look how hard it is to get your printer to work. Think of a quantum printer where a slight change in temperature could stop it from working.
Yeah.
No, it'd be disastrous. So I don't know if quantum computer will ever reach the home. I think you'll get big quantum computers like I think Google's Sycamore computer. I think it is. I think you'll have a lot of those, but whether they'll ever be really useful, I'm not. Maybe not in our lifetime. I don't know.
Right.
Should we play Fact or Reset?
One more question.
Sorry.
Do you know much about the Younger Dryas theory?
The what? Sorry.
The Younger Dryas theory.
No.
No. Okay,
No,
I'll leave
absolutely
it at
nothing about it.
I'll leave that on. Yeah.
No, fill me in. Tell me what
it's apparently about human existing a lot longer than we thought, like 15,000 years ago or something, where there's a meteor shower that goes past every, I think it's 2,000 years, and it's close to Earth, and you can track it. And apparently that meteor hit Earth like 15,000 years ago and basically wiped out everything and basically reset humanity. And they're saying that everything that happened back then, we had a human civilization that was probably as clever as us, but on a different path. So maybe they could have moved things with the mind or something like that, using chemicals in the air and stuff like that.
It's an interesting idea. I'd be looking for kind of signs of where it hit, and
they've got actually coverage of where like some of it hit and where the floodings happened, and some like underground temples and stuff that was actually made before we thought humans existed.
Well, that's fascinating. The idea of, I imagine that humanity, as we've existed as an intelligent species, I imagine we've gone through quite a few resets.
Yeah.
Because if you think about it, before we had kind of like global connectivity between civilization and civilization, it probably wouldn't have taken that much to reset a society. So something like a flood, something like an earthquake, might actually wipe an entire society and everything they know from existence. It might be completely destroyed. I mean, if you look, there's a chance humanity might have forgot more than it knows currently. On like a kind of global scale, I'm less inclined to believe that's possible.
Right.
And I doubt that we had some kind of psychic power, or we could we could manipulate matter with our minds at some point in the past, and like we lost it. It's a good idea for a sci-fi.
Yeah.
It's fascinating.
Yeah. Anyway, we'll get on to the fact or reset game. I don't know if James told you about it.
No.
Nope. Okay.
I don't know. I don't think I heard this bit.
Right. So the aim of the game is.
What do I win?
You go on the leaderboard. That's behind us.
Awesome. That's more valuable to me than money. That. I thought I was going to get a yacht like on Bullseye.
James got 2, so that's the score to beat.
Oh, right, okay.
Yeah, so James is in 4th place. I don't care
about beating anybody else, just want to beat James.
Yeah, so James is in 4th place.
Yeah, so the aim of the game is I give you some facts, and you tell me if it's a fact or if it's a load of waffle, then you say reset.
Right, okay.
And you keep going until you're on the board, so you get at least 1 point. So
that's a low bar. Stephen.
Yeah, I'll play the jingle.
Stand clear.
It's fact or reset.
So we'll start. A group of slugs is called a sludge. Fact or reset?
Reset.
Yep, you're on the board.
That was a tough one.
This one's a UK-based one. It might be hard though. The Spice Girls were originally a band called Touch.
Reset.
No, it's a fact. So you got one.
I knew the Spice Girls would get me one day.
So you're just below James. I'll have to work it out alphabetically.
Where you were. Stuff that we're talking about? Quantum physics and cosmology. What good is it when I get humiliated by the Spice Girls? I've wasted my life.
Oh,
that's what kids are for.
Yeah.
What, taking your frustration out?
So educated on more modern stuff.
Why didn't you tell me the Spice Girls were called Touch once? Go
Well, that's all the questions I've got.
Yeah,
anyway.
it's been great chatting with you. It's another educational, mind-blowing episode that was.
Yeah.
Enjoyed it.
I was saying to Stu, I don't know if I'm ready for all this learning. It's too early. I'm not used to this.
Yeah, it's a bit much early in the morning before you've had your coffee, isn't it?
Yeah. All right. Thanks for coming on anyway.
Yeah, it's been great chatting with you.
It's a fascinating universe, and I didn't even get to tell you what happens when you drop a marshmallow on a neutron star. So we'll have to save that for next time.
I mean, have you got time before you?
I've got a couple of minutes.
Yeah.
It explodes. That's it. It explodes with about as much energy as hundreds of thousands of atomic bombs. Because
what if you drop a marshmallow on a star?
Yeah, on a neutron star.
Right.
Do you know what a neutron star is?
No.
There you go. There's some reading to do.
Right.
Okay.
I recommend articles by this This young up-and-comer called Robert Lea. He's brilliant.
I've heard of him somewhere.
Yeah, brilliant.
All right, thanks for coming on.
Yeah, brilliant. Thanks for chatting with us.
They're my favourite things. Everybody loves black holes, but I prefer neutron stars.
Okay.
Right, I'll do a bit of research
We'll have
on
a look
that
at
one.
that.
All right. Thank you.
Thank you very much.
Right, bye-bye.
Bye.
Bye.
Have a good day. Thanks for
And you
listening,
too.
everyone.
And you.
Right.
We'll carry on and we'll have to get the audio from that and pull it across.
Oh, if you can do that successfully.
Hopefully. I better be able to.
I can't go through that again.
Oh, no. Has that happened?
I don't know. What have you done?
Don't know.
You paused it though, did you? I don't think you clicked it going, did you?
I did. I started it again. Oh my god! I just recorded the whole chat and never recorded it. So I'm hoping the video. I can pull the audio from the video. Hopefully,
Yeah, I should imagine you would.
should be able to, shouldn't I? 125. Yeah. Should be able to pull the audio from that.
Yeah, well, we can recover from this. I'm sure.
Yeah. Well, that's 1 minute. Well, 1 hour 25 minutes. You have to get off soon, don't you?
I'll have to, yeah, because I've got to get ready for work.
Yeah, you're gonna get ready for work.
And if you've already listened, if you listen to this when it's released, I've just finished work.
Yeah. So this will be released on the Sunday
Yeah.
when you're listening.
Well, I finished work.
Yeah.
I'm not working at the weekend.
Oh, I've got one more question for you before you get off.
Go on.
So, Oliver has a friend that lives nearby. I won't say which one, but he always wants to go in their house. The problem we have is they both smoke drugs.
Yeah.
How do you tell an 8-year-old that they can't go in the house because the parents smoke drugs?
I'm sorry, son. You can't go in that house because his parents are druggies.
Straight up. Just be straight with him.
No, I just
You're going to learn something today.
I just say something like that. That funny smell that you can smell that comes out of the house.
Yeah, yeah.
It's not very good for you, and
Yeah.
and we don't want you
Yeah.
around that.
Right.
That's the way I'd do it.
Yeah.
He's more than welcome to come to our house,
Yeah.
but you're not coming to theirs.
Oh, well, he would ask some questions if I said that. What is it? Why?
Sorry, when your older son.
Yeah. I've not even done news.
Oh no!
Have we got time?
Got 5 minutes.
5 minutes. Let's get straight to the news. I'm kidnapping Stu because he wants to go to work. Don't know why he wants to go to work, but. A man in India recently found a massive gold nugget while washing clothes in a river. The nugget weighed over 8 pounds and was estimated to be worth around 346 grand.
Wow.
Yep, that's a lot. In Ontario, Canada, where loads of guests have been from lately.
Our friends are.
Yeah. A group of 4 cows escaped their farm and wandered into a local home. The cows reportedly made their way into the living room and even took a nap on the couch before they were eventually herded out.
Who let these bloody cows into my house?
A man in the UK claimed to have discovered a chicken nugget in his McDonald's meal that was shaped like a character from a video game, Among Us. The man posted a picture of the nugget online, which quickly went viral. And then the last one. A Texas man recently built a giant, functional robot out of scrap metal and old car parts. The robot, which stands over 20 feet tall, can move its arms and legs and even has a flamethrower attached to one arm. And that's all for the ChatGPT news. Over to you, Stu.
It's looking sunny outside.
It is. And it's not as warm as last week, though.
It's not as warm.
Brilliant.
Just going back to that thing about the man built a robot, they've done that in Japan.
Have they?
And you can sit in it and operate robots.
Really?
That fire stuff.
That's mental, that.
James May, our man in Japan, the TV series.
Right.
Have a look at that.
Will do. Crazy. Right. Anyway. So we've got a lot of research to do now.
Got a lot of
There's
research.
2 things, yeah. We've not had any emails this week, so I've had none to read. So please keep them emails coming in. So you can email us at contact@getfact.co, and the website to subscribe and follow is www.getfact.co. Please send emails in to keep us knowing that you're still listening, and pretty soon we'll hopefully have some merchandise to buy if you want to, like, if you want to support us, I don't mind. Anyway, keep them coming in, and that's the end of the show. Hopefully I can get the audio from the video. It was nice to have a backup, wasn't it? Just guess.
Did you have just in case? I imagine that.
I was on about stopping that as well because he didn't have video. So
Good job he didn't.
yeah, that's all from us. Anyway, I hope you enjoyed the show, and I hope it wasn't too much for your brain because it hurt mine.
It ain't mine.
Have a lovely day.
Have a good day.
Peace out.
Cue the music.